today's experiment we will do analysis of series RC circuit using NI-Elvis board. This is the circuit that we need to connect the peak voltage for the input and output and the phase shift between the input and output signals. The first thing we need to do is connecting the function generator of the feedback board with the NI-Elvis, the function generator, channel 0 and channel 1. Here I connected the function generator of the green board with the NI-Elvis, channel 0 and channel 1. Before connecting anything to the board, let's see what we will need. We will need one capacitor, 470 nanofarad, and the R load is 10 ohm. R1 will be changed during the experiment. Now we want to decide, do we need to connect the function generator with the amplifier or directly the function generator to the circuit? How we can decide this? This device gives us the peak 5 volt. So the maximum peak to peak we can get is 10 volt. Let's see our circuit. Here we have the amplitude is 20 volt peak to peak. 20 volt peak to peak is higher than 10 volt peak to peak. Then we need to use the amplifier. First, we need to connect the grounds. The ground of channel 1 with the ground of channel 0 with the ground of the function generator and the ground of the amplifier. A ground, it means what? 0 volt. So here we have the 0 volt. We will connect this pin to this pin to this to the 0 volt. Now we will take the output of the function generator and amplify it to have a higher peak. Now the signal, after going from the function generator to the amplifier, the output of the amplifier is the amplified signal of the function generator. يعني الفانكشن جنريتر رح يعطينا output signal. الاوتبوت سيجنال محتاجين نكبرها. رح ناخد الاوتبوت من الفانكشن جنريتر يروح as input للامبليفاير. الاوتبوت of the amplifier is the signal. We will take it inside the circuit. Let's see our circuit here. This is the output of the function generator, which is here will be the output of the amplifier. So here we have the output of the amplifier. Going first to the first resistor. The first resistor we will have will be 1 kilo ohm. Then it's connected in series with 470 nanofarad capacitor and then connected in series with 10 ohm. So how we will do this? The output of the amplifier will be connected to 1 kilo ohm. We have in our board two elements have the value of 1 kilo ohm resistor. We will choose one of them and make sure the one we will use its input port and output port. We can take this port of the first 1 kilo ohm and the output port of the second one. Then we will have an open circuit. So the output of the amplifier will be connected to the 1 kilo ohm resistor. This 1 kilo ohm resistor is connected in series with 470 nanofarad capacitor. This one. So I'll connect the output of the 1 kilo ohm resistor to the input of the 470 nanofarad. Now the output of the 470 nanofarad capacitor will be connected to the 10 ohm resistor. So I'll take the output port of the capacitor and connect it to the input port of the 10 ohm. In our board, this is the 10 ohm and this is the 100 ohm. Don't be confused with this one. This is 10 kilo ohm. So we'll use the 10 ohm. Then go back to our to the diagram. We have the second port of the 10 ohm connected to the ground. Here we connected all the ground together. This is a ground, this is a ground, this is a ground, and this is a ground. So we can connect the second port of the 10 ohm with any ground port we have. So here I'll take wire from the output of the 10 ohm and connect it to this ground. Now I have a full connected circuit. We need to read the input and output signals. So we have to connect the oscilloscope channel 0 and channel 1. We'll go back to the diagram. Let's say that channel A is channel 0, channel B is channel 1. Now, channel A, we look for the positive port, okay? Here the positive and here the positive. Channel A, which is channel 0, the positive is connected where? Is connected to the output of the signal. And remember, here we have the output not from the function generator, we have the output from the amplifier. Or to make it easier, here this is the same port, right? Channel 0 is connected to the input port of the first resistor. For each element, we have 2 ports, input and output. So channel 0, the positive port, is connected to the input of the 1 kilo ohm resistor. Hence, we will go here and take wire from the channel 0 port to the input of 1 kilo ohm resistor. The same thing we'll do with channel 1, which is here channel B. Channel 1, channel B. We'll go to the positive port. Check, this is the positive. We'll go, it's connected where? The output of the capacitor or the input of 10 ohm, the R load. So I'll take a wire from channel 1 to the input of the 10 ohm. Let's see how we can do the analysis. When we turn on the NI-Elvis device, we will have this screen in our computer. We will need 2 things, the function generator and the oscilloscope. This is the function generator and this is the oscilloscope. First, we have to set the function generator for the experiment we are doing. We need to set the voltage value, peak to peak, the frequency, and to make sure that we have what? Sine waves. One thing we have to remember, that we are using the green board, right? Since we are using the green board, we have here to go to the signal root and change it to be FGen BNC. We have 500 Hertz. So I'll go here and change the frequency to 500 Hertz. Now the voltage peak to peak. I need it to be 20 volt peak to peak. So here I can't put 20 directly. I can't know directly the gain of the amplifier I'm using. That's why we will start testing our amplifier. I'll start with a 3.5 V peak to peak. يعني احنا عم ناخد السيجنال الاوتبوت سيجنال من الفانكشن جنريتور على الامبليفاير. لو انا ما بستخدم الامبليفاير بحط الفي بيك تو بيك نفس اللي مكتوب في الجدول. طالما انا عم بستخدم الامبليفاير فمعناه الفاليو اللي راح تكون مكتوبه هون مو هي الفاليو اللي راح تطلع لي، لان الامبليفاير له جين راح يكبر لي السيجنال. كل سيركت كل جرين بورد الامبليفاير تبعها له قيمه جين معينه. احنا ما بنعرف السيركت اللي احنا موصله عندنا قد ايه بالضبط الجين تبعها، فاحنا بنبدا نظبط الانبوت وستت، بعدين ناخذ قراءه الاوتبوت. بلش في قيمه بتساوي مثلا 3.5 في بيك تو بيك، ونشوف قديش رح تتكبر باستخدام الامبليفاير اللي وصلنا. After setting الامبليتيود والفريكونسي we'll go and turn the circuit on. After turning the circuit on we will run. Here we have the frequency that we set, 500 Hertz. We'll go to the oscilloscope. We need to set the input. To set the input is connected to channel 0. So we'll care about the green signal for now. We don't change anything in the beginning. We go and press run. Okay. The value that we can take from here, actually it's the mean value of the signal shown in this square. الفاليو اللي مكتوبة تحت هي المين فاليو للسيجنال اللي موجودة داخل السكوير. طالما السيجنال فيها قراءات أو فيها البيك سيجنال طالعة برا الويندو، we can see from here and we can see from here. مو كل الساين ويف بقدر إني أشوفها داخل الويندو. then لازم أضبط السكيل. we have to adjust our scale. How we adjust the scale? We are going to change the peak values, right? The scale of the y-axis. The scale of the y-axis is the voltage scale. If we are changing the time axis, we'll go to the time scale. Now we will start with the y-axis, which is the voltage scale. I have to increase it. See, after increasing it, the value changed. It was 10, now 13, because now all the signal is inside the window, and this is the mean value of the signal. In our experiment, we need the peak-to-peak value to be 20, and we have it here 13. So we'll press stop, and also we press the stop. After trying some values, I'll try 5.3 volt peak-to-peak as input for the amplifier. I'll press run. I'll go and press run for the oscilloscope. So channel 0 value, the reading is V peak to peak 19.98, which is almost to 20, the value that I need as an input to the circuit. Now I adjusted the input. We need to take the reading of the output.